Hello, my name is Hila, and I'll be presenting the work TargetCLIP, Image-Based Clip Guided Essence Transfer, which is a collaboration between Tel Aviv University and the University of Copenhagen. First, let's discuss some intuition. Humans can identify semantic properties independently from the target ID. For example, all the images below are perceived by humans as images of the Joker, even though each image depicts a different actor, meaning a different identity. We ask the question, can AI do the same? i.e., can AI detect the semantic properties that are perceived by humans as corresponding to the Joker without mixing in identity-specific properties?
Now that we've seen our intuition, we can move on to the definition of essence transfer. Given a single target image IT, our goal is to extract an essence vector B that corresponds to the textual description of the target image IT. For example, if our target is the Joker, our goal is to extract an essence vector B such that we can add the vector B to each source vector to get an edited image with the identity of the source and the features from the textual description of the target image. For example, here, the identity of the result still corresponds to Kate Winslet, but the semantic features are taken from the Joker.
Let's discuss the method we use to extract an essence vector B for the target image IT. First, it's worth mentioning that our method uses a batch of n source images to avoid identity loss of the sources and obtain a global essence vector B. At step 1, our method inverts the source images IS1 to ISN to their corresponding latent vectors, which we notate by Z1 through Zn. Later, we add the proposed essence vector B to each one of the latents. After the first step, we have n latent vectors, Z1 plus B through Zn plus B, which represent the edits applied to the source images by the essence vector B. We use the SAGN generator in order to generate the edited images from the latent vectors. Now that we have our proposed edits, Z1 plus B through Zn plus B, we can apply loss terms to optimize the essence vector B. We apply two main loss terms, L similarity and L consistency. This is the formulation of L similarity, where C is the CLIP image encoder. This formulation actually means that we're demanding that each edit, Z1 plus B through Zn plus B, is semantically similar to our target image IT. Moving on to L consistency, our goal is to ensure that the semantic properties added by B are not specific to the source identity, but are global for all the sources. We do that by making sure that the semantic properties added to all the sources are the same, i.e., the difference between the source after the edit and the source before the edit is identical for all sources. To obtain the final loss term for our optimization, we combine the similarity and consistency losses with an additional L2 regularization term. We propose two methods to extract an essence vector B for each target image. The first is a direct optimization of this total loss term for each target image IT, which is longer but more accurate, as can be seen from Figure 3. The second option is fine-tuning an existing inversion encoder to output the essence B of an input image instead of outputting the latent Z for the input image. This is quicker in inference time, but is less accurate, as can be seen from Figure 4 here.
Finally, we compare a method against existing methods for style transfer, domain adaptation, and text-based semantic editing. We test the FID, the preservation of the source identity, and the semantic transfer of properties from the target to the sources. Results marked in red in the table indicate underfitting, meaning that no semantic properties are transferred from the target to the sources, as can be seen in Figure 5 here. Results marked in orange in the table indicate overfitting, meaning that there's a high identity loss of the source identity, which can be seen in Figure 6. Our method is the only one that is able to preserve the source identity, while also transferring the semantic properties of the target. Thank you, and please check out our code.